The moon is not what you think it is. Say that again and let it sink in. The moon, that pale, familiar disk that has hung above every war, every birth, every sleepless night in all of human history, is not what you think it is. For 53 years since the last Apollo astronaut pressed his boot into its dust in December of 1972 and climbed back into the lunar module, we told ourselves a comfortable story, a dead rock, a gray companion. Geologically silent, fully mapped, chemically understood, and essentially boring. We put it in science textbooks and moved on to deeper questions. We stopped looking. And then, on April 6, 2026, 4 astronauts aboard the Orion spacecraft swung around its far side, the half that permanently faces away from Earth, the half that no human eye had ever witnessed directly since the Apollo program. And what they found there didn't just challenge our assumptions, it shattered them in a matter of hours. Through the windows of a spacecraft the size of a large van, 4 human beings stared at a landscape so ancient, so violent, and so structurally bizarre that one of them, a decorated Navy captain who had spent 168 days aboard the International Space Station and survived re-entry from orbit, said the words out loud that the rest of us were thinking in silence. That human beings probably have not evolved to see what they were seeing. Pause on that. A trained astronaut, a man who has experienced more extremes than nearly any person alive, and even he could not find the vocabulary to describe what he was looking at. Drop a like right now if that sentence alone gives you chills, and if this is your first time here, hit subscribe. Because this channel is where we go past the headlines and into the actual science of what just happened, what the Artemis 2 crew saw, what it means, and why the moon we think we know is a story we've been telling ourselves for far too long. Let's start from the beginning. The crew, the rocket, and the most dangerous ride in the solar system. Their names are Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. 4 human beings chosen from thousands of candidates, trained for years, and assigned to a mission that has no margin for the ordinary. Wiseman serves as commander. Glover is the pilot, the first black astronaut to travel beyond Earth orbit. Koch is the mission specialist, the first woman to venture into deep space. Hansen, a Canadian Space Agency astronaut, is the first non-American to leave Earth's gravitational influence entirely. Every single one of those firsts matters, not as symbolism, as a statement about who gets to explore the universe from now on. They launched from Kennedy Space Center at 6:35 in the evening on April 1st, 2026. And no, that date is not a joke, though reality has a sense of humor about these things. Their ride was the Space Launch System, or SLS, the most powerful rocket NASA has ever successfully launched. It stands 322 feet tall. At liftoff, it generates 8.8 million pounds of thrust. To put that in perspective, the entire weight of the Statue of Liberty is roughly 450,000 pounds. The SLS produces nearly 20 times that force just to get off the ground. The sound alone registers as a physical force you can feel in your chest from miles away. Within minutes of launch, they were in orbit. Within less than 5 minutes of a single engine burn, they were on a trajectory toward the moon. The speed at which this happens is hard to comprehend. There is no gradual departure, no leisurely leave-taking. One burn, less than 5 minutes long, and the Earth is falling away behind you at thousands of miles per hour. The path they followed is called a free return trajectory. This is a specific arc through space, calculated precisely, such that even if the spacecraft's engines had failed completely after that initial burn, failed totally with no chance of recovery, the gravitational field of the moon would have caught them, bent their path around the lunar body, and slung them back toward Earth on its own. No engines required, gravity doing all the work. the physics of orbital mechanics as your only emergency system. Apollo 13 flew the same type of trajectory in 1970, and it is the only reason Jim Lovell, Jack Swigert, and Fred Hayes came home alive after their oxygen tank exploded en route to the lunar surface. The free return trajectory saved 3 lives. It is the safest route to the moon, which also tells you everything you need to know about what going to the moon actually involves. When the safest option accounts for total engine failure as a baseline scenario, you are not taking a vacation. You are doing one of the most dangerous things a human being can do. But here's what people don't fully appreciate. The danger isn't mostly in the launch. It's not the rocket that will kill you. It's what comes after. It's the radiation, the isolation, the months of physiological stress, the psychological weight of knowing that the nearest help is not just far away. It is, in the most literal sense, unreachable. We're going to talk about all of that, but first we need to talk about what they actually saw. The far side, a world within a world. To understand why the far side of the moon is genuinely unsettling to scientists, you have to understand just how different it is from the side that you and I have been staring at our entire lives. The near side, the face of the moon that permanently points toward Earth due to a phenomenon called tidal locking, is covered in vast dark plains called Maria. That's Latin for seas, because when Galileo looked at them through his telescope in 1609, he thought they looked like water. They're not water. They're ancient lava flows, enormous volcanic events that occurred between roughly 3 and 3.5 billion years ago, filling enormous craters with molten basalt that then cooled and solidified into the flat, dark plains we see today. About 31% of the near side's surface is covered in this volcanic rock. It gives the moon its recognizable pattern, the man-in-the-moon face, the shapes we've been projecting stories onto since before written language existed. The far side has almost none of it, less than 1%. Instead of smooth volcanic plains, the far side is a continuous wall of craters stacked on top of craters stacked on top of still older craters. Impact events going back 4 billion years, recorded in the surface like rings in a tree, each layer preserving impacts that the near side had erased under rivers of lava long ago. Looking at the far side is like looking at the raw geological memory of the early solar system. The near side shows you what the moon became. The far side shows you what the solar system was like when it was still violent and young and chaotic. And the structural differences don't stop at the surface. The crust on the far side is roughly 50 kilometers thicker than the crust on the near side. 50 kilometers. That's not a measurement error. That's a geological divide so enormous that scientists still can't fully agree on why it exists. The leading theory involves a catastrophic impact event early in the moon's history, a collision so violent near what is now the South Polar region that it sent a plume of superheated material rippling through the moon's entire interior, forcing rare Earth elements and radioactive materials to migrate toward the near side, effectively baking it from the inside out, while leaving the far side cool and thick and unyielding. That impact left a scar, and it is the largest preserved impact structure in the entire known solar system. The South Pole-Aitken Basin, the wound that never healed. Picture a hole in the ground. Now scale that hole up until it is large enough to swallow an entire continent. The South Pole-Aitken Basin stretches roughly 2,500 kilometers across. It plunges up to 13 kilometers below the surrounding terrain. If you placed it on a map of the continental United States, it would swallow everything from the Texas Gulf Coast to the Virginia coastline. If you stood at its deepest point, the rim walls would disappear over the horizon before you could even see them. The mountains along its rim reach elevations of 8,500 meters, comparable to the tallest peaks in the Himalayas. This is not a crater. It is a continental-scale wound in the surface of a world, and buried beneath its floor, something is hiding. In 2019, a team of researchers led by planetary geophysicist Peter James at Baylor University published findings that shook the planetary science community. They combined gravitational data collected by NASA's Grail mission, two spacecraft that mapped the moon's gravity field by measuring how they were pulled toward each other as they orbited, with high-resolution topographic measurements from the Lunar Reconnaissance Orbiter. What they found was a mass anomaly sitting at least 300 kilometers below the Basin floor. A concentration of dense material so enormous that it is warping the local gravitational field. This object, this buried mass, weighs a minimum of 2.18 quintillion kilograms. James described it as roughly equivalent to burying a pile of metal 5 times larger than the Big Island of Hawaii, somewhere beneath the lunar surface. It is heavy enough to drag the entire floor of the basin downward by more than a kilometer. The most plausible explanation? It's the metallic core of the asteroid that punched the hole in the first place. A dense iron-nickel mass that hit the moon so hard and fast that it didn't bounce back into space. It punched through the crust, decelerated in the mantle, and stopped. And there it has sat, motionless for 4 billion years, like a bullet fragment lodged in tissue that the body never managed to expel. The wound healed around it, the basin filled with geological time, and the bullet remained. The Artemis II crew became the first human beings to see the eastern rim of this basin with their own eyes. Not through the lens of a robotic camera, not in the processed false color images from an orbital spacecraft. Through the actual windows of the Orion capsule, in real time, as their vessel swept past at over 60,000 miles per hour. The Apollo astronauts never saw it. Their flight paths didn't take them over the relevant portions of the far side, and the solar illumination angles weren't aligned correctly for observation. Artemis II's trajectory was calculated specifically to expose as much of the far side as possible to direct sunlight from the crew's perspective, and it delivered roughly 21% of the far side surface to human eyes for the very first time. Are you watching this for the first time? Then you are learning something right now that most people on Earth don't know. Hit subscribe so you don't miss what comes next, because we're just getting started. What they actually saw, the 7 hours that changed everything. The science observation period lasted 7 hours. 7 hours during which 4 astronauts with cameras, trained eyes, and scientific briefings fresh in their minds swept over a landscape that had never been seen by human beings. They had trained for this. They had spent time in Iceland and other volcanic terrains, learning to recognize and describe geological features in real time, because when you are moving at more than 60,000 miles per hour and have seconds to observe any given feature before it disappears behind you, you have to be prepared. Christina Koch noted almost immediately that the smaller, more recent impact craters were shockingly bright compared to the ancient surrounding surface. She described them as tiny pinprick holes in a lampshade, glowing white against the dull gray terrain. This observation is scientifically valuable. Fresh craters on the moon are bright because the impact exposes unweathered regolith, rock and mineral material that hasn't been bombarded by billions of years of micrometeorite impacts and solar wind, which gradually darkens and chemically alters the surface in a process called space weathering. The relative brightness of a crater tells you its age, and Koch's eye caught distinctions that orbital cameras had not fully resolved. Victor Glover became particularly fixated on the terminator, the shifting line that divides the sunlit portion of the moon from the shadowed portion. Along this boundary, the geometry of sunlight creates something almost hallucinatory. Craters transform. Sunlight strikes their rims at extreme angles, only a few degrees above horizontal, casting shadows so deep and so perfectly black that they look not like shadows, but like holes punched entirely through the moon's surface. Glover radioed back that the Terminator was full of magic, that the islands of light in the darkness and the valleys that looked like holes you could fall through to the center of the world were unlike anything he had seen. This was not metaphor. It was direct visual observation from a trained pilot and engineer describing what his eyes were actually registering. Meanwhile, Christina Koch and Jeremy Hansen were simultaneously observing and photographing Vavilov Crater, a feature perched on the rim of the older and considerably larger Hertzsprung Basin, one of the largest impact structures on the far side. The science evaluation team in Houston was watching everything the crew reported in real time and updating the observation plan accordingly, sending new targets and adjusted camera settings based on what the crew was seeing, because human eyes in orbit can catch subtleties that no automated system fully anticipates. The crew also reported something that surprised even experienced lunar geologists: color variations across the surface that no existing orbiter image had fully captured. Shades of brown and muted green on the near side. Subtle blue tints in certain regions of the far side. Color gradations that the human eye can distinguish, but that cameras, with their different spectral sensitivities and processing algorithms, tend to flatten into a uniform gray. These color variations matter enormously because they reflect differences in mineral composition. Iron-rich regions look different from titanium-rich regions. Highlands have different spectral signatures than mare basalts. The ability to observe these distinctions with trained human eyes from a known vantage point and cross-reference them with existing spectral maps could refine our understanding of lunar mineralogy in ways that purely robotic observation had not. But of all the features they observed, the one that may have generated the most scientific discussion was one they spotted before they even reached the far side. What do you think was the most surprising thing they saw? Drop your answer in the comments. I read every single one. Reiner Gamma, the ghost marking that shouldn't exist. Before the Orion spacecraft crossed to the far side, it swept over Reiner Gamma, one of the most baffling features on the entire surface of the moon. It looks, at first glance, like someone dragged a bright white paintbrush across the dark lunar surface in a sweeping, swirling pattern. It has no elevation. It casts no shadow. It is not a crater, not a volcanic deposit, not a geological structure in any conventional sense. It is purely a surface marking, a bright optical feature with no physical relief, and it sits directly on top of a localized magnetic anomaly. This requires some background. The moon does not have a global magnetic field. Earth has one, generated by the movement of molten iron in its outer core, which acts like a planetary dynamo, generating the field that deflects solar wind and cosmic radiation and makes compasses work. The moon lost its magnetic field billions of years ago. Its interior cooled, its core stopped moving, and the dynamo shut off. Yet scattered patches of magnetized rock persist in the lunar crust. Remnants, ghosts, really, of a field that existed and then died. Like a city after the power goes out, with certain rooms still inexplicably lit. Reiner Gamma sits on top of one of these magnetic patches, and scientists have been arguing for decades about what the relationship actually is. The leading hypothesis is that the magnetic anomaly is somehow shielding the surface beneath it from the full force of solar wind bombardment. Solar wind, streams of charged particles continuously blasting outward from the sun, gradually darkens and chemically alters lunar regolith through a process called space weathering. If a localized magnetic field is deflecting some of that solar wind, the surface beneath might retain its original brightness, creating a light marking that traces the shape of the magnetic field itself. But not everyone is convinced. Alternative hypotheses include the idea that a comet impact long ago flash magnetized the crust while simultaneously blasting away the darker surface material, exposing brighter substrate. Or that something about the surface chemistry in that region simply responds differently to solar irradiation. The Artemis II science team flagged Reiner Gamma as a priority observation target. The crew photographed it as they swept past, capturing it at angles and lighting conditions that no orbiting camera had previously obtained. The full scientific analysis of those photographs will take months, but the fact that trained human eyes and high-resolution cameras observed this feature from a crewed spacecraft in real time, with the ability to adjust framing and focus based on immediate visual feedback, is exactly the kind of observation that robotic missions cannot replicate. The solar eclipse that lasted 54 minutes, and the flashes in the dark. As Orion dipped behind the moon, the sun slid behind the lunar disk, and then it disappeared. From Earth, a total solar eclipse lasts a maximum of about 7.5 minutes. That's the upper limit imposed by geometry, the relative sizes of the sun and moon and the distance between them. People travel thousands of miles for those 7 minutes. They describe them as transformative, terrifying, unlike anything else in human experience. The Artemis II crew experienced totality for nearly 54 minutes. Victor Glover described the corona, the sun's outer atmosphere, normally invisible against its blazing disk, as bright enough to ring the entire moon in a halo of white fire. Jeremy Hansen reported that the sun was illuminating the full perimeter of the lunar disk during totality, throwing the topography along the lunar limb into sharp silhouette. Mountain ridges and crater rims visible as black shapes against the burning white of the solar corona. The visual experience was, by every account, unlike anything in the human photographic archive. And then, during the eclipse, during those 54 minutes of impossible darkness and corona fire, Hansen and Wiseman reported seeing impact flashes on the lunar surface. Brief, instantaneous, bright points of light that appeared and vanished faster than the eye could fully track. The moon has no atmosphere, nothing between its surface and the violence of open space. Every micrometeorite, every pebble, every cosmic particle that crosses the moon's orbital path hits the surface at full speed, with nothing to slow it down or burn it up. When they hit, they release energy instantly, a brief flash of impact vaporized material, glowing at temperatures of thousands of degrees Kelvin, visible from orbit for a fraction of a second, before fading entirely. For centuries, observers on Earth have reported what are called transient lunar phenomena, brief flashes, color changes, and apparent glows observed on the lunar surface through telescopes. Some of these are almost certainly micrometeorite impacts. Others may be electrostatic dust events, or outgassing from the interior, where trapped volatile materials briefly escape through fractures in the crust. The scientific community has long struggled to confirm and classify these events because they are unpredictable, brief, and difficult to verify with the equipment available from Earth's surface. The Artemis II crew may have witnessed at least one confirmed impact flash from orbit. Both Hansen and Wiseman confirmed seeing a brief burst of light. Scientists in the Houston evaluation room requested immediate clarification, exact location, duration, intensity. The crew provided what details they could in the time available. Whether this constitutes the first human eyewitness confirmation of a lunar impact flash from orbit will be determined when the full photographic record is analyzed after splashdown. But here's what it tells us even before that analysis. The moon is not passive. The moon is not still. The far side, permanently turned away from Earth, permanently bombarded without witness, is an active target in an ongoing cosmic shooting gallery. And we've been pointing our telescopes at the other direction this entire time. The thermal anomaly and the granite that shouldn't exist here is something that should not be on the moon. And yet, it is. In 2023, a team of researchers analyzing data from China's Chang'e 1 and Chang'e 2 orbiters, combined with microwave temperature measurements taken over multiple lunar day-night cycles, detected a thermal anomaly buried beneath the far side surface. a region approximately 50 kilometers wide that consistently registers roughly 10 degrees Celsius warmer than the surrounding terrain. Not at the surface, beneath it. A buried heat source sitting under kilometers of lunar rock, radiating warmth that bleeds upward through the crust like heat from a buried coal seam. The most probable source? A massive block of granite. This requires explanation because granite on the moon is close to scientifically inexplicable. On Earth, granite forms through a process called magmatic differentiation, combined with the presence of water and active plate tectonics. Silica-rich magma, with water dissolved in it, crystallizes slowly under pressure into the coarse-grained, chemically distinctive rock we call granite. It is one of the most common rock types on Earth's surface. It is essentially unknown on the moon. Because the moon has no water, no plate tectonics, the conditions required to form granite simply do not exist in the standard model of lunar geology. And yet, there it is, buried under the far side, still warm. The researchers believe the most likely explanation involves a now extinct volcanic system, a magma chamber that existed roughly 3.5 billion years ago, and then went dormant as the moon's interior cooled and volcanic activity ceased. As the magma cooled, chemical differentiation occurred. The more silica-rich components of the melt separated out and crystallized into what appears to be a granite-like body. The remaining heat from that cooling process, geologic heat, almost impossibly slow to dissipate, is still bleeding outward today, detectable only by the most sensitive remote sensing instruments. Lead scientist Matt Siegler, commenting on the discovery, noted that this formation looks far more like what we would expect on Earth than anything previously observed on the moon. And it raises a question that nobody expected to be asking in 2026. If granite exists on the moon, what else are we wrong about? What other geological processes that we assumed required Earth-specific conditions might have occurred under conditions we didn't anticipate? The Artemis 2 crew could not directly observe this buried anomaly. It's underground. But the surface above it was within their observation window, and the images they captured of that region may help future researchers correlate the surface expressions of this buried structure with its thermal signature. Does this change everything you thought you knew about the moon? Because it should. Let me know in the comments what surprises you the most about all of this. The lava tubes. Sealed mysteries beneath the surface. One of the most consequential and least discussed aspects of the moon's hidden geology is what lies beneath the surface entirely. Not buried asteroids, not thermal anomalies, tunnels, lunar lava tubes, vast underground channels formed by ancient volcanic activity, have been detected across the moon through a combination of radar data from orbiting spacecraft and high-resolution imaging that has identified collapse features known as pit entrances. Circular openings in the surface, typically 50 to 150 meters across, where the roof of an underground tunnel has partially caved in, exposing the cavity below. On Earth, lava tubes form when the surface of a lava flow cools and hardens, while liquid lava continues flowing beneath it, eventually draining out and leaving an empty tunnel. Hawaiian lava tubes can be tens of meters wide and kilometers long. They're walking tour destinations for tourists. On the moon, because gravity is only about 38% as strong as on Earth, and the ancient lava flows that created them were considerably larger, lunar lava tubes could be orders of magnitude bigger. Theoretical modeling suggests some may be kilometers wide and hundreds of kilometers long. Structures large enough to shelter entire cities, if intact. The key phrase is, if intact. We do not actually know. We have never sent a robotic probe into a lunar pit entrance. We have detected their existence from orbit, but their internal dimensions, their structural integrity, whether their ceilings have remained stable across billions of years of micrometeorite bombardment and moonquakes, all of this is unknown. What might be inside them? The temperature within a sealed lunar lava tube would be significantly more stable than the surface, where temperatures swing from over 120 degrees Celsius in direct sunlight to minus 130 degrees Celsius at night. The interior of a sufficiently deep and sealed tube might hover near minus 20 degrees Celsius year-round. There could be deposits of volatiles, water ice, carbon dioxide, other compounds, preserved in the cold and darkness. There could be pristine volcanic rock completely unaltered by billions of years of surface bombardment. There could be materials that have simply never been exposed to the space environment. Or the tubes could be collapsed, fractured, and structurally compromised at every scale we care about. We genuinely don't know. What we know is that they exist. What we know is that several proposed landing sites for future Artemis missions are within range of identified pit entrances. What we know is that the people planning humanity's return to the lunar surface are already thinking about what's underneath it. The Artemis 2 crew could not enter or directly observe any pit interiors from their orbital altitude. But the reconnaissance photographs they took, combined with their human eye observations of surface texture variations and shadow behavior, will contribute to the site selection decisions that determine whether a crewed mission ever descends into one. The radiation problem, the invisible killer that engineers can't fully solve. Here is the most important thing nobody at NASA's press conferences says clearly enough. The radiation environment of deep space may be the single greatest obstacle to long-duration human spaceflight. Not propulsion, not life support, not the psychological effects of isolation, though those are serious. Radiation. When you are inside Earth's magnetic field, whether standing on the ground, flying in a commercial airplane at 35,000 feet, or orbiting in the International Space Station, you are inside a protective bubble. Earth's magnetosphere deflects the vast majority of charged particles streaming from the sun and from distant cosmic sources. It's not perfect protection. Astronauts on the ISS receive considerably more radiation than people on the ground, which is part of why long-duration ISS missions are studied so carefully. But it's protection. The bubble exists. It does something. Beyond it, there is nothing. Artemis 2's crew spent approximately 10 days in deep space during solar maximum, the peak of the sun's 11-year activity cycle, when the frequency and intensity of solar particle events is at its highest. The sun, at solar maximum, regularly ejects massive bursts of charged particles in events called coronal mass ejections, or CMEs. A severe CME can deliver radiation doses exceeding hundreds of millisieverts within hours. For context, the annual exposure limit for radiation workers in the United States is 50 millisieverts. A severe CME in deep space, without adequate shelter, can deliver more than that in a matter of hours. The Orion capsule provides significantly more radiation shielding than the Apollo command module ever did. It is equipped with a specially designed radiation storm shelter, essentially a small area of the cabin where the crew can huddle while instrumentation, food, and water storage is arranged around them to provide additional mass shielding. The Artemis 2 crew had protocols. They had procedures. They had trained for exactly this scenario. None of that eliminates the risk. It manages it. And then there are the galactic cosmic rays. These are a different problem entirely. Solar particles are energetic, but they can be largely blocked by sufficient mass, enough shielding material, and you can deflect most of the dose. Galactic cosmic rays are a different order of physics. These are particles accelerated to nearly the speed of light by supernovae, neutron star collisions, and other cataclysmic events across the galaxy. They carry so much energy that they can penetrate almost anything we have built. A thick lead wall that would stop solar radiation completely provides only partial protection against galactic cosmic rays. The particles that get through create secondary particle showers inside whatever material they hit, including the human body. Alexandra Stankovich, founding director of the Center for Space Medicine Research at Massachusetts General Hospital, has called deep space radiation, in her words, the showstopper, the #1 limitation on how far humans can travel. Her team, along with researchers at dozens of other institutions, is currently testing everything from experimental radioprotective drug compounds to dietary antioxidant regimens to highly speculative gene therapy approaches borrowed from organisms like Deinococcus radiodurans, bacteria that can survive radiation doses 1,000 times higher than would kill a human, thanks to extraordinarily efficient DNA repair mechanisms. The Apollo astronauts received relatively low radiation doses because their missions were short, a few days of transit time, a brief surface stay, and return. Even so, some Apollo astronauts developed cataracts at statistically higher rates than their non-spacefaring peers. The sample size, exactly 24 people who have ever left Earth's magnetic field, is far too small to draw definitive conclusions. But the pattern is there. Artemis II's crew carried with them something called the Avatar payload. Bone marrow cells derived from the astronauts' own blood samples, placed in a specialized container and exposed to the deep space radiation environment throughout the mission. When the spacecraft returns to Earth, scientists will analyze how those cells responded, which genes were activated, which were suppressed, what damage was done, how repair mechanisms responded. That data, from actual human cells exposed to actual deep space radiation during actual solar maximum, is worth more than any number of theoretical models. And here's the thing that doesn't get said enough. The radiation problem gets dramatically worse as missions get longer. Artemis II lasted about 10 days. A crewed Mars mission would last somewhere between 2 and 3 years, round trip. The radiation dose scales accordingly. There are researchers who believe, based on current data, that a Mars round trip would deliver enough galactic cosmic ray exposure to meaningfully elevate lifetime cancer risk and potentially cause measurable cognitive impairment. Radiation-induced damage to brain tissue, specifically the hippocampus and prefrontal cortex, which animal studies have shown are particularly vulnerable to the type of high-energy particles that constitute galactic cosmic radiation. This is not science fiction. This is the published, peer-reviewed literature. And it is the reason NASA's Human Research Program has radiation listed as one of its top 5 research priorities for deep space exploration. Not budget constraints, not public support, biology. What do you think? Should we keep sending humans into deep space knowing this risk? Vote in the comments. I want to hear where you stand. The 40-minute blackout. Alone in the oldest place in the solar system. On April 6, 2026, at approximately 6:44 in the evening Eastern Time, the radio signal between the Orion spacecraft and mission control in Houston disappeared. This was expected, planned for, built into the mission architecture from the very beginning. When the spacecraft passed behind the Moon on its far-side transit, the 3,400-kilometer mass of solid rock between it and Earth would block every radio frequency at every wavelength. There was no workaround, no relay satellite, no alternative communications path. The signal simply stopped. And for the next 40 minutes, 4 human beings were more isolated than any people who have ever existed. Understand what that isolation means physically. They were 252,756 miles from Earth, farther than any human in history, beating the record set by Apollo 13 in 1970. Between them and the nearest other human beings was not ocean, not desert, not the vacuum of low Earth orbit. It was 2,160 miles of solid Moon. Lunar rock so ancient and so dense that nothing electromagnetic could pass through it. Their spacecraft had all systems functional. They had oxygen, water, food. They had their suits. They had protocols for every emergency their trainers had been able to imagine. And if a solar particle event had struck during those 40 minutes, If the sun had ejected a burst of high-energy radiation in those specific 40 minutes, Mission Control would not have known until the signal came back. The crew would have known. They would have seen their radiation monitors spike. They would have activated the storm shelter protocol, moved to the designated protected area of the capsule, consulted the procedures for radiation emergency response. They would have done everything right. And Houston would have watched the telemetry resume 40 minutes later and seen, in the data, exactly what had happened. That is the reality of deep space. The delay between event and response is not communication lag of seconds. It's not the 24-minute round-trip light-speed delay of a Mars mission. It's total radio blackout, zero information flow, and the crew is on their own. Victor Glover tried to describe what he was seeing in real time, sending observations back to Mission Control during the minutes before the blackout, knowing they had only moments before the signal died. He said he was watching the Terminator, the sunlit craters, the depths of shadows that had never been photographed at this angle. He tried to put it into words. And then the signal cut out at 6:44, and there was nothing. For 40 minutes, the four of them were sealed in a spacecraft smaller than a studio apartment, surrounded by the oldest, most cratered, most radiation-soaked landscape in the inner solar system, with no connection to home. No voice from Houston, no telemetry, no heartbeat signal from Mission Control confirming that Earth still existed and that anyone was waiting. Just the four of them, the windows, the gray and black landscape below, and the silence. When the signal returned, Mission Control in Houston erupted. The crew's voices came back through the static as Orion cleared the lunar limb and Earth reappeared in the windows. They reported that they had watched Earth set behind the lunar horizon during the approach to the far side, a slow, silent disappearance of the pale blue crescent of home, sinking below gray cratered rock until it was gone entirely. The image NASA later released, captured through the spacecraft window and dubbed Earthset, is the mirror of the famous Earthrise photograph taken by Apollo 8 astronaut Bill Anders on December the 24th, 1968. In that image, Earth rises above the lunar horizon, bright, colorful, impossibly alive against the gray of the moon and the black of space. It became one of the most reproduced photographs in history. In the Earthset image from Artemis 2, Earth is leaving, sinking, vanishing, the same planet, the same pale blue dot, just disappearing behind the far side, going somewhere human beings had never gone before. Christina Koch described the moment with a clarity that cut through every technical formality of mission communication. She said, "When you have that perspective and compare it to home, it reminds you how much we have in common, that everything we need, Earth provides, and that you can't truly understand that until you've seen it from the other side." The names they left behind. The crew of Artemis 2 had the authority to name 2 craters observed during the flyby. They chose carefully. The first they named Integrity, after the mission's unofficial nickname for the Orion spacecraft, a name that began as shorthand and evolved into something more philosophical over months of training together. The second they named Carol. Carol was Reed Wiseman's late wife, Carol Taylor Wiseman, who passed away in 2020. It sits on the boundary between the near side and the far side of the moon, a feature visible from Earth if you know precisely where to look. Jeremy Hansen described it simply as a bright spot on the moon. There is a certain quality to that description that resists elaboration. A bright spot on the moon, a name given to a feature that will exist for geological time, in a place that no weather will ever erode, no ocean will ever fill, no vegetation will ever cover. The moon has no atmosphere to carry erosion. Its craters persist for billions of years because nothing removes them. The name Carol will sit on the lunar surface, attached to that bright spot, for longer than our civilization has existed, and longer than it will likely last. That is one kind of legacy. The moon holds it now. The records, the numbers, the scale. The Artemis 2 mission set the farthest distance from Earth that any human being has ever traveled, 252,756 miles. The previous record, held by the crew of Apollo 13, stood for 56 years. At closest approach, the Orion spacecraft was moving at approximately 60,863 miles per hour relative to Earth. The observation window over the far side lasted 7 hours. Thousands of photographs were taken. Due to communication bandwidth limitations, the full image archive had not yet been downlinked at the time of this broadcast. The data transfer will be completed after splashdown. Splashdown was scheduled for April 10th, 2026, off the coast of San Diego. The crew spent the transit home falling back toward Earth at speeds that gradually decreased as Earth's gravity reclaimed them. The entire mission, from launch to splashdown, spanned 9 days. 9 days during which 4 human beings traveled farther from Earth than any person in history, saw features of the moon that no human eye had ever witnessed, collected photographic data that planetary scientists will spend years analyzing, and, perhaps most importantly, demonstrated that the architecture works. The SLS rocket works. The Orion capsule works. The life support systems, the radiation protocols, the communication infrastructure, the crew selection, it all works, which means the next mission can go further. Artemis 3 will attempt an actual landing on the lunar surface near the South Pole, targeting permanently shadowed craters where water ice is believed to be preserved in quantities large enough to support future operations. The crew observations from Artemis 2 will directly inform where that landing happens, which sites look safest, which terrain features suggest hidden hazards, which shadows behave in unexpected ways along the terminator. A site that looks flat and safe in an orbital image can look entirely different to a trained human eye, observing the way shadows pool and shift in the extreme, low-angle sunlight near the lunar poles. Artemis 2 just gave the mission planners 7 hours of that kind of observation over terrain that had never been seen by human eyes at the exact illumination angles that matter for surface operations. That is not a secondary product of the mission. That is one of its primary scientific purposes. The far side as a scientific instrument. The scientific value of the far side extends beyond what the Artemis 2 crew could observe visually from orbit. The far side possesses a characteristic that makes it unique not just on the moon, but in the entire inner solar system: permanent radio silence. From the far side, Earth is permanently below the horizon. Every cell tower, every broadcast transmission, every Wi-Fi router, every radar installation, every radio telescope, every communication satellite, all of it is blocked by 3,400 kilometers of solid rock. The electromagnetic noise of human civilization, which has been increasing exponentially since the invention of radio in the 1890s, cannot reach the far side. It is, in terms of radio frequency environment, the quietest place accessible from Earth in the entire solar system. For radio astronomers, this is not a convenience. It is a transformational opportunity. Earth's ionosphere, the layer of charged particles in the upper atmosphere, blocks radio frequencies below approximately 30 megahertz. This means an entire frequency band is completely inaccessible to any radio telescope on Earth's surface. Low-frequency radio waves, emitted by the early universe, by the hydrogen that dominated the cosmos before the first stars formed, by the cosmic dark ages between the Big Bang and the first light. These signals exist, they travel through space, and they arrive at the moon. But Earth-based radio telescopes cannot detect them because the ionosphere reflects them back into space before they reach the ground. A radio telescope on the lunar far side could detect these frequencies for the first time. It would be listening to an era of cosmic history that no observatory on Earth has ever been able to observe directly. Multiple space agencies have proposed exactly this: a low-frequency radio array on the far side of the Moon, using the lunar body itself as a natural radio frequency shield. China has already taken a step in this direction with its Queqiao relay satellite, parked in a halo orbit above the far side to maintain communications with Chang'e 4. The relay infrastructure already exists. The science case is overwhelming. The Moon isn't just hiding secrets on its surface. It is offering humanity a tool to hear the rest of the universe more clearly than we ever have. The Chinese missions and the contested frontier. The Artemis II crew were not the first to explore the far side. They were the first humans to see it directly, but robotic explorers had been there before them. On January 3, 2019, China's Chang'e 4 lander touched down inside von Karman crater, a 186-kilometer wide impact feature on the floor of the South Pole-Aitken Basin, and became the first spacecraft in history to land softly on the far side of the Moon. The technical challenge was enormous. Without a direct line of sight to Earth, the lander required a dedicated relay satellite, named Queqiao, meaning magpie bridge, positioned in a halo orbit above the far side to bounce communications between the spacecraft and Earth. The Yutu-2 rover, deployed from Chang'e 4, found minerals at the landing site consistent with olivine and pyroxene, materials from the deep lunar mantle that the South Pole-Aitken impact had excavated from hundreds of kilometers below the surface. This was the first direct compositional evidence from the Basin floor, and it confirmed what geologists had long suspected. The SPA impact was so violent, so deeply penetrating, that it brought material from the Moon's mantle to the surface. Material that otherwise would have remained buried forever. In 2024, China went further still. The Chang'e 6 mission landed in a different region of the far side, collected surface samples, sealed them in a return capsule, and launched them back to Earth. The first time material from the far side had ever been returned for laboratory analysis. Scientists at institutions around the world are currently working through those samples, analyzing isotopic ratios, mineral assemblages, and volatile content in rock and regolith that formed and evolved completely isolated from the solar wind weathering that has altered the near-side's surface chemistry over billions of years. The results of that analysis will reshape our understanding of early solar system history. The far side is already the frontier. Multiple nations are already operating there. And the Artemis II crew, the first human eyes to observe it directly, arrived at a moment when the question of who knows this terrain and who can operate in it is no longer merely academic. Subscribe to this channel and turn on notifications. Because as the Artemis program progresses and those Chinese sample analyses come in, we are going to cover every development in real time. What Artemis II actually tells us, and the harder question it raises. Let's talk about what the mission actually means, not the press conference version, the scientific version. We have spent centuries looking at the Moon's face and calling it understood. We landed on it 6 times between 1969 and 1972, and we collected 382 kilograms of rock from a handful of carefully selected sites, all on the near side, all within a relatively narrow band of accessible terrain, all chosen for safety rather than scientific diversity. We built comprehensive models of how the Moon formed, how it evolved, how it cooled, and we built those models almost entirely on near-side data. That's like landing a spacecraft in the Sahara Desert, collecting sand samples from a 50-kilometer radius, and declaring that you understand the entire geology of the Earth. The Sahara is real. The sand is real. The data is accurate, but it is a local data set. And the far side is not the Sahara. It is Antarctica, and the Himalayas, and the deep ocean floor, all in one place. A fundamentally different geological environment that our models were never built to describe. The South Pole-Aitken Basin, with its buried metallic mass and its excavated mantle material, doesn't fit neatly into the standard lunar formation model. The far side granite anomaly doesn't fit neatly into our models of lunar volcanism. The crustal thickness asymmetry between the near and far sides doesn't have a universally accepted explanation. The magnetic ghost patterns imprinted on a crust that lost its planetary magnetic field billions of years ago don't fit neatly into anything. The moonquakes, shallow seismic events detected by Apollo's surface seismometers in the 1970s, still being recorded and analyzed by instruments today, suggests that the moon's interior is not as dead and motionless as we assumed. Every answer the far side gives us opens 3 more questions, and the questions keep getting harder. Victor Glover said it plainly after Orion cleared the far side and Earth reappeared in the windows. The moon is not just a poster in the sky that goes by. It's a real place. He is right. It is a real place. And the more we learn about it, the less comfortable that fact becomes. Because it is a place that keeps forcing us to rewrite what we thought we knew. The granite that shouldn't be there. The mass that doesn't match. The asymmetry that no single theory explains. The heat sources that haven't fully cooled after 3.5 billion years. The impact history recorded in layers of craters that the near side erased long ago. All of it is still there. All of it is still waiting, and we have barely begun. The Artemis 2 crew is on their way home, falling back toward Earth at speeds that human beings weren't built to comprehend, riding a trajectory shaped by Newtonian physics and half a century of accumulated engineering knowledge, carrying with them the first direct human observations of the moon's hidden hemisphere in more than 50 years. When they splash down in the Pacific, they will step out of the capsule and blink in the California sunlight and give press conferences and talk to their families and sleep in real beds for the first time in 9 days. And when the scientific analysis of their photographs is complete, when the spectral data is processed and the crater maps are updated, and the geologists have had months to compare what the crew saw with what the orbiters predicted they would see, the story of the moon is going to get longer and stranger and more complicated. Not just a poster in the sky, a real place, full of questions we didn't know to ask, and we've barely started asking them. Before I go, what was the most mind-blowing thing you learned in this video? Drop it in the comments right now. Seriously, I love reading what lands for people. And if you're watching this without having subscribed yet, what are you waiting for? We cover the actual science of space exploration here. No hype, no clickbait, just the real story. Hit subscribe and the bell icon so you never miss a video. I hope you enjoyed the video. If you did, please give it a like. It genuinely helps this channel reach more people who want to understand what's actually happening in space exploration. Subscribe if you haven't already, because the Artemis program is just getting started, and every mission from here is going to be bigger and stranger and more important than the last. We're going to cover all of it. I'll see you in the next one.